Welcome back. This is the second lesson recording for IM1, April 13th, 2021. So let's summarize some of the key things from the Desmos. Well, transformation is when we move original shape. We sometimes call that pre-image. The original shape is called the pre-image or the object to another new position without changing its original shape. That's what we mean by transformation. Okay, so and there are four types of transformation. The first one is translation. That's where you shift. There's a reflection. That's when you flip the image. And rotation is that's when you turn the image. Dilation is shrinking or stretching. Okay, dilation we're not going to do too much work on. You're going to be doing that in IM2, but for now in IM1 we're going to be focusing mainly on translation, reflection, and rotation. And to explore that, you are going to be working on card number 8 to 13 of Desmos. Here we go. Okay, so card number 8, exploring rigid transformation. The first one we're going to explore is translation. So on this slide, you will explore a way to move shapes called translation. Start by moving the red points to make a shape you like. Okay, so again, you can make it any shape you want. Okay, try to make it sort of not symmetrical. Okay, so you can move any shape like this. Okay, and you can also move the purple point where you like. Okay, so you can move that and that's going to translate the translation endpoint. This is the translation endpoint. Okay, so then afterwards, you next slide the green slider. Look what happens. We started with the original image, made a copy of it, and then we just moved it along the translation endpoint here. This is what we call translation. We are sliding it. Shifting or sliding the image along the path that you can define. You can make it go down or at a diagonal, or you can make it go up. You can do any point, and then so again it's going to be sliding up and down or cross along where you are defining it to be. Okay, in your own words, based on this exploration, what does it mean to translate the shape? What are you doing when you're translating this shape? Okay, so the red is the original, black is the image that you have translated. You are sliding it along whatever the pathway. Okay, so you're picking one point and you're sliding it along. And look what happens to the shape. Is the shape changing at all? Is the orientation changing at all? Is the size changing at all? Think about that. And that is what you're going to be answering here. The black shape is called the image. The image is the end product of the shape after translation. Describe how the image of the shape after translation compares to the original. Make sure to describe location. Is the location the same? Well, after transformation, the location is not the same, but it moves along the pathway where you've defined it. And the orientation, well, looking at this, it's still pointing to the top left and top left here. The orientation, the angle, and the turnedness, which is not really a proper English word, but you know what that means. Okay, so the orientation, whether it's standing up, standing towards the side, or flat across, or whatever, or pointing downwards, or whatever, that would be the orientation. What about the size? Is the size the same? Well, if I put it right on top, it's exactly the same. That's what we started off with. And the shape, angle between the sides, are they the same? Well, orientation is the same, size is the same, shape is the same. The only thing that has changed is the location in this case, isn't it? All right, now we're going to be exploring rotation. On this screen, the red shape will be rotated around a given point. Move the red dot to make whatever shape you want. Okay, again, you are going to create a shape that you want. Okay, so let's just say this is my shape, and then move the purple point somewhere. Okay, so that is the point of rotation. The point of rotation is over there. Whereas I move this, look what happens, and look, we're describing it in terms of angle. Okay, and move it all the way, and when I do that 360 degrees, brings it all the way to where it started off with. Okay, but and then we can go backwards, and if I stop here, say 90 degrees, I'm not sure whether I can make 90 degrees. Look what happens. Or if I make it 180 degrees, where is it? Okay, so it's over there. Right, so what's happening? It's as if you've put a pin right, you've traced this, you've traced the image right here and put a pin right there, and then started moving that traced paper. And that's, you are turning about that point of rotation. So with rotation, there is a point of rotation. And I can move that anywhere. And what happens if I move that inside the shape? It's just changing within. Okay, there you go. So this is a transformation called rotation, where we are turning the image. So how does the rotation affect the location, orientation, size, and shape? So first of all, is the shape changed? Okay, it still looks like that, I don't know what you call them, maybe boomerang shape. And it is still the same boomerang shape all the way around. Okay, what about the size? It's still the same size. What about the orientation? Well, the orientation looks like it's pointing to the left here, but then it points down, points down, points down. It changes the direction. The orientation is changing all the time. Okay, so the location is also changed. Okay, and it also depends on whether the point of rotation is. Location can change significantly if the rotation point is outside the shape or within the shape. The location is changed slightly less, but the orientation is completely different. So it's not the same, is it? Okay, there is definitely a difference from the rotation. Okay, so with rotation, the locations changed, orientation is changed, but the size and the shape remains the same. Exploring rotation again more. Looking at the orange lines carefully, play around with the slider and point and examine how they behave. The lines show how the red points are moved to the black points. Okay, so if I move this, if I rotate this, look what happens. Okay, each of the vertices, each of the sort of corners of the shape, if I just keep tracing that, creates a circle. What does that mean? A circle is defined by a point that is equidistant or same distance from the center. So the rotation point is the center. So we're saying what's going on is that the distance from the center or the rotation point remains the same. That is the reason it's creating a circle by each of the vertices of this shape. Okay, so the distance from the point of rotation remains the same. Okay, now lastly is the reflection. In this graph, the black shape is the image of the red shape. Red shape is the original, and you can change the shape anywhere you want over the purple line. And line of reflection. Line of reflection is where you're putting the mirror. Okay, so it's the mirror image. Okay, so this is the black is the mirror image of the red shape here. And you can see that I can move the mirror image, and that's going to change where the new image, the reflected image is going to be. And if I change the original shape, obviously that's also going to change the image as well. Okay, but it is as if I put a mirror right along here, and it's creating a mirror image. And think about, describe the image in terms of its location. The location is very different. Okay, what if I moved it right, the line of reflection within the shape? It is still being reflected. Look what's happening. It's flipping, isn't it? Okay, it's flipping. So even if it's inside, it's still not going to be the same image. So with this, the location is changed, the orientation is also changed. Is the size different? Size is the same, and the shape is also the same. It's just a flipped version of the shape. And when we're talking about the flipped version of this shape, we still call that the same shape. All right, then let's putting it all together. The word rigid means unable to change its shape. It is essentially opposite of flexible. Okay, so when something is rigid, or when somebody says, oh, you are so rigid, it means you're not very flexible. So it is opposite to flexible. That means it cannot, the shape cannot be changed. So based on this exploration, why do you think we call this transformation rigid transformation or rigid motions? Well, that's because with reflection, translation, and rotation, the shape and the size remains the same. Okay, that remains the same. The only thing that changes is the location and the orientation. So going back to our slides, you're going to take notes here. We are going to be exploring the three transformations that we just talked about. The first one is translation. Translation is where you are shifting or sliding the image. So do you see the image of the two dancers here? Okay, so looking at this dancer, she is making this sort of, her orientation is pointing up to the left, and the new image is also pointing up and to the left. So the orientation is exactly the same, the size is the same, and the shape is the same. Okay, so the only thing that is different is location, where it is. It has been shifted to the right in this case, as well as yeah, the only thing that is changed is location. Okay, the orientation stays the same, the size stays the shape, and shape stays the same. In fact, size and the shape is the same for all of them. That's why we call it rigid transformation. And the shape is the same and orientation is the same. What about reflection? It is what we call flip or mirror image. Okay, so it's as if there is a mirror right in the middle here and we're flipping it. So what happens with translate reflection? The shape is the same, but the orientation is different. Here it looks like the guy is jumping towards the left. Here it looks like the guy is jumping towards the right. What about rotation? It's what we call turn. The shape is the same again, but the orientation is again different. It is as if he's upside down here while as he's kicking up here. Okay? And we'll continue on the next leg recording.